Hello and welcome to another video. In this video we're going to be working on minimum operations to make array values equal to k. And it looks like it actually doesn't have that high of a success rate, which is kind of interesting for an easy. But yeah, in this one, so you have an array nums and an integer k. And an integer is called valid if all values in the array that are greatly stricter than h are identical. So here, like if h is 9, then everything greater than 9 is 10, so it is identical. And 5 is not, because all of these are greater than 5. So you're allowed to perform the following operation. Select an integer that is valid for the current values in nums. For each index where the number is greater, turn it to h. And then return the minimum number of operations required to make every element equal to k. And if you can't, return -1. So in this they tell you want to use 4 and 2. So like the main thing you want to figure out is like what's the actual strategy I have. So you need to turn everything into 2, but like what would be the best way to do that? So if you have a bunch of numbers that are greater than 2, the only number you can pick to turn things into has to be any number between the second greatest and the greatest number. So in this case, it has to be between 4 and 5, I guess just 4. Like turning 5 into 5 would do nothing, but let's say our array was like 1, 2, 3, 6, 6, 6 or something. We can turn everything into a 3, like we can turn these into a 4 or a 5 or a 3. So what would be the best? And you're just always going to want to turn everything into the second biggest number all the time, because that's how you get everything down. So essentially we just pick 3 and then we turn all these into 3. And then if we want to turn something smaller, then we pick 2 and so on and so on. So that's kind of like the pattern. And then whenever you have a number that's less than k, so you're always able to turn everything into k if every number is bigger than k. So like if k is 1 here, you can. But if you have a number less than k, you can only make numbers smaller. You can never make them bigger, because essentially we're taking numbers bigger than a number and we're decreasing them. So if we have a number less than k, we can't do it. So basically we have to check for that. We have to check like, okay, is every number bigger than k? If not, return -1. Otherwise, how many operations do we need? So let's look at this example. So if we want to turn everything into 1 here, like I said, we're taking the number and we're turning it into the second biggest. So we'll go like this, then we'll turn everything into a 5, then we'll turn everything into a 3, and then we'll turn everything into whatever it is. So essentially, at every step, like every operation kind of gets rid of a number. And so the answer here is how many numbers do we need is just number of numbers greater than k. So in this case, if it's like this, 3, 5, 7, 9, it would be 4, because we turn everything into this guy, then everything into this guy, then everything into this guy, and then everything there into k. And so that's all we have to do basically, is we just have to check, is there a number less than k? If yes, return -1. Otherwise, return the number of numbers that's greater than k. And because we just need a count, so we can do this in O of n space and constant, or O of n time in constant space. So we'll just have a count here, and let's have a I guess that's all we need actually. So nums. So if num is less than k, we can just return false right away. And if num is greater than k, count plus plus. Oh, actually, so we do need one more thing. So we need to we need to avoid duplicates, right? So for example, let's say our array is this, and this can be in any order, and we have no way of knowing this. So we need to avoid duplicates, in which case we can just use like a hash set of numbers that are seen. So we can just create that, and we can just say like set uniques. And then we can check if number is greater than k, if uniques doesn't have it, I guess, yeah. So if uniques contains it, then we do nothing. So if it doesn't have it, or we can even write it in once, if number is greater than k and uniques contains the number, if that's not the case, then we will increment the count. And actually, we don't even need the count now that I think about it, because the count is just going to be the length of uniques, right? Uniques is just going to be all numbers greater than k, so we can just do this. So if uniques doesn't have it, we'll just add it in. Actually, we don't even need this either. We can literally just say uniques. So uniques will be the set of numbers that are greater than k. Then we can just return that. So uniques size. There we go. I think that should do it. So yeah, I don't think you can do O1 space actually, because you need to account for duplicates. You can do a sort. So either a sort that would be O1 space, because then you can avoid duplicates with a sort, or or this works. You can't do like a binary search or something because they're not in order. If they were in order, you could binary search them as well. Actually, no, you couldn't, because you can have duplicates still. But yeah, so I think this is the best. So here, linear. Okay. So yeah, that's gonna be all for this one. Hopefully you liked it. If you did, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.